Yeah, so welcome to the lecture 5, and that's a crop growth factors and the growth laws we will be discussing here. So, previous week we have given a introductions about the crops, that's a crop ecosystem and the agroclimatic zones, and what is the growth and development, because that indicates proper the input management by proper understanding of this growth and development. These lectures, particularly growth factors and growth laws, that will guide you, because every the processes, they are governed by some scientific laws. So, here we will explain you that the different scientists, they have worked on the early ages, and they have found some of the experimental understanding that has become a law, actually growth law, and that is applicable for this crop production systems. So, let us come to this one, this growth laws as you discussed the earlier. So, this already I have discussed the growth phases, how the crop growth that changes because with the time. Already we have explained earlier classes the sigma the growth curve, the S shaped with the lag phase, and this is the log phase or say exponential phase, where the crop growth rate increases at increasing rate, and this phase is highly crucial or the critical we can say for your the input management. So, also this phase, this also very critical for this, in these two phases are the very essential for this proper input management. So, the growth is governed by the internal factors, that is genetic factor and the physiologies and this external factors like environmental factors, then your the managements, agronomic management, input management, how you are doing. So, this understanding that helps the proper input management, that we have discussed in details in the earlier class. So, there are the physiological basis of the crop growth you can see. So, how the photosynthesis that converts the light energy to the carbohydrates at the basis of the growth. Then we have the respirations that releases energy, loss of energy, particularly for the maintenance of the crops. Then transpirations, that we have the regulates the leaf temperature, we discussed also last class, and the drives the nutrient movement. So, transpiration is a productive loss of water. Then asymmetric partitioning, say energy, nutrients to productive organs. So, the transformation of the carbohydrate from the canopy to the storage parts or the grain parts, that is a assimilation partitioning, that is a process of the transformation source sink relationship. Then you have the hormones are there, that is they regulate the growth, because there is a auxin, gibberellin, cytokinin, abscisic acid. Auxin, gibberellin, cytokinin, these are the growth promoters, and the ABA, abscisic acid, the growth retarders. So, because they balance each other. So, there is a balance between the growth promoter and the growth retarder, then the proper growth happens. Then the integration of the all the physical environment process that makes a crop growth. So, with this already I have discussed the basics are the the inputs, actually the components of this crop production systems, these growth laws. So, we will discuss what are the laws, existing laws in the crop growth and the yield formation, yield simulations. These are the already growth factors we have discussed. So, I do not want to go very detail on these. So, these are the area already the aerial factors and the edaphic factors. So, these are the existing area, they are the weather parameters and the soil parameters. We have discussed it in detail also in the previous classes, how they influence this are the crop growth. So, comes to the growth laws here. So, there are different scientists, they have given the different laws. So, first one is the Liebig's law of minimum. So, that is a growth limited by the very scarcest nutrients, very limited nutrients which is limited. So, that influence the growth. So, what we say in a soil there are you need the 17 essential elements. So, all the elements are present, but if the one element is absent, then the growth is affected. So, that is the growth is limited by the scarcest resource, the one element, that is a deficit or absence, then the growth will be affected, that is a law of minimum. Then the law of optimum. So, each factor has an optimum range for the growth. So, E factor has to be optimum levels for a proper maximizing production, that is the law of optimum. Then other one is the Blackman's law of limiting factors. If the growth is processed towards rapidity by several factors, so growth is limited by the slowest factor. If the one factor is limiting, also that same as law of minimum said living, the Blackman's law of limiting factors. The finally, what we are the crop production, we are seeing the Mitscherlich growth law. So, that quantifies the law of minimum, the Liebig's law of minimum, that is expressed in the quantitative term by Mitscherlich, that is a Mitscherlich growth law. So, this law particularly we focus on discussing this now as a law of minimum, which governs now because of the limiting factors, this the resource, how the resource limits the crop productions, and the of course, these are the related one. Then finally, the Mitscherlich growth law, which existing now, how the growth or the yield is influenced by the input management, that as per the Mitscherlich growth law. So, coming to first one, Liebig's law of minimum. So, this Justus von Liebig, this is the scientist. So, he proposed a law of minimum in 1840. So, what he said, this is the Liebig said crop yield is limited by the nutrient in minimum supply if all other nutrients are adequate. So, what is say now by, so if all the nutrients are present adequate, but one nutrient is in limited supply, that limits the crop growth. Also, he has told by deficiency or absence of one essential constituent, the soil is rendered as barren to all those crops to the life of which that constituent is indispensable. That means, if that constituent or the element is indispensable, that is essential elements, if the essential element that is absent or deficient, then crop growth is limited. So, that means the soil is known as a barren for that crops. Even though they have soil has all other nutrients optimum, but one nutrient is absent or deficient, then crop growth will be affected. So, he has given an example like a water tank example. If you see this water tank, so these are the different plates in the wooden barrel of water tank. So, plates are of different height, some are the maximum height, some are like boron. These are the each plates he represented as a particular nutrient for the crop growth, each wooden barrel. So, these are the like different cobalt, nickel, copper, manganese, zinc, boron, carbon, nitrogen, phosphorus. So, these are the some nutrients that are optimum, there is a amount is maximum, and some nutrients they are in lowest amount. In this case, as a wooden barrel, if you want to hold water, suppose how much water you can hold? The water can be retained only to the levels where the barrel height is the minimum one. You can hold here water only up to this level, because here there is a gap, this height. We cannot hold water more than this height, though the barrel is has the maximum height, because the water will leak from here. To increase the holding of the water, then we have to raise the height of the wooden barrel to certain levels like this level, then you can hold water to this level. When you come to this level, then you have to increase the height of the the level, we can hold more water. Similarly, in case if this each wooden barrel they represent a particular element, and you say all the elements are in optimum amount, only one element either absent or deficit, then you cannot attain a maximum growth. The plant cannot give you a maximum growth. To have the maximum growth, the requirement, how much requirement of that element, that requirement has to be maintained. If that element is essential, because every element is indispensable, because elements play a critical role in crop growth and development. Their deficiency are very specific in action, they cannot be replaced by other elements. So, that is what the law of minimum that says To have maximum growth, you must ensure that all the elements who are essential elements that must be satisfied the need of the crop, then you can have the maximum growth. So, that is what the example is with the nitrogen deficient, adding more phosphorus, potassium cannot increase the yield, because nitrogen is an essential element. You cannot replace the effect of nitrogen with phosphorus, other elements. This law implies that plant growth is controlled by the limited factors, that is scarcity factor, the one element, that is essential element that cannot be replaced. We have to supply the amount. So, what is the limitation of this law? Do not account for the interaction among nutrients definitely, and ignore the soil moisture, temperature and other light. It takes about the nutrient, the crop nutrient, how the crop nutrients are regulated. And the other law, the law of the Blackman's law of limiting factors, that is when a process is conditioned to its rapidity by several factors and the rate of the process is limited by the slowest factor. If any factor is a lower amount, if the process is goes to optimum, if any that is environmental factors you can say, if one like light, the radiations, if there is optimum radiations, optimum CO2, the crop the growth is maximum. If the temperature is minimum from the required levels, if the lower from required level, then even though you have the light or the carbon dioxide, their optimum levels, we cannot attain maximum production unless until the temperature is maintained at the desired levels. That is what say law of limiting factors by Blackman, he has proposed in 1905. So, come to next the very important one, the Mitscherlich growth law, who explained the law of minimum in quantitative terms. So, law of minimum says by deficiency or absence of one necessary constituent, the crop is the soil is rendered barren to all those crops, the life of which that constituent is indispensable. That talks about the law of minimum. If that element is not present or present the minimum, the not in proper amount, then you cannot attain the maximum production for a particular crop from that soil. Then this state, suppose you know that that element is limited, then how much to be applied that element? What is the quantity of that element we should apply, so that we can get maximum production. So, that is a extension of the law of minimum in a quantitative term, that is a Mitscherlich growth law. What is state? That increase in yield with each increment of a growth factor, a particular growth factor is progressively smaller and proportional to the decrement from the maximum yield or the gap from the maximum yield, we can say. That means, every addition of the growth factor that causes the low addition in the output. That is what the increase in yield with each increment of growth factor is progressively smaller. So, that is what is explained by the this law. I can give you some. So, this is suppose y is the yield of a crop with particular input x1 and A is the maximum yield that can be attained. So, nutrient supply, the x axis, that is a kg per hectare, the y axis the yield of the crop kg per hectare. So, this is the nature of the relations of the input applications with the crop yield. So, if you apply the particular inputs x1, you get the y1, if you go for x2, you will get y2, and if you go on increasing to the particular the xn, the nutrient level, you get A the maximum yield. So, so here what you say, the change in yield with the change in input, that is proportional to the increase in yield with each increment growth factor is smaller and proportional to the gap from the maximum yield. So, so here in case this growth law, this is the x, suppose nutrient, x is a nutrient, that is a kg per hectare, that is your input application, nutrient as input kg per hectare, this is the yield as output y axis, this is also kg per hectare. So, this relationship input applications, this is the maximum yield. Suppose x n, the A is the maximum possible yield. If you go for the x 1, first input x 1, you get y 1, increase the input to x 2, you get the yield y 2. So, this is the change dy by dx. Again you go on adding inputs to second level, you get the dy. Go on adding inputs, you get the dy. So, what the last states? Increase in yield with increasing growth factor is progressively smaller. This difference of yield increase as you go on adding the growth factor, that goes on decreasing, and that is proportional decrement from the maximum. Suppose you are the maximum possible yield, the A. So, this is the difference from A minus y 1, this is the A minus y 1, and this difference goes on decreasing as you go on adding growth factor. If you go to second growth factor, so this difference y 2, this difference is A minus y 2. So, now A minus y 2, the gap is minimizing, the gap is decreasing. So, what it says, the increase in yield dy with is proportional to A minus y. A is the maximum possible yield, y the yield realized with the growth factor x. So, as you go on change, this is dy is decreasing. As you go on adding the growth factors x 1, x 2, x 3, x 4, then x n. So, dy is decreasing, and similarly A minus y, the difference from the maximum possible yield from A minus y, that is also goes on decreasing. So, dy by dx is proportional to A minus y, or we can say dy by dx is equal to A minus y into C, proportionality constant, or you say that is expressed as log A minus y is equal to log A minus C x. So, this is what the Liebig's law of minimum, log A minus y. A is the maximum possible yield, y the yield realized with the growth factor x, and x is your input, C is the proportionality constant. So, that is a increase in yield with increase in growth factor is progressively smaller, dy that goes on decreasing as you go on adding growth factor, and that is proportional to decrement from the maximum. As this goes on decreasing, the gap also goes on decreasing. That means, every addition of the successive growth factor, that adds lower yield as compared to previous growth factor. That is the law of, you can say, law of diminishing return as well. This is what the you can see the Michaelis growth law, that is what the explained by this one, log A minus y log A minus C x. If you see this one, like, so with increasing yield, as you go on the adding any growth factor, as we discussed this earlier one. So, with each addition of successive growth factor, that yield goes on decreasing, and so after this law of minimum, if you say law as a log A minus y log A minus C x, if you follow this one, suppose then the Ball came, the scientist Ball, after that he explained the how the if you divide this the x axis to 10 equal units, suppose you are applying fertilizers. So, x n, in case x n, that gives the 200 kg, suppose x n, in case 200 kg of nutrient input, suppose you are applying the nutrient x n is equal to 200 kg per hectare, that gives the A maximum possible yield 6000 kg per hectare. So, at 100 to 200 kg per hectare of the nutrient applications, you get the maximum yield A is equal to 6000 kg per hectare. So, what it will, if you divide this x unit, the maximum nutrient applications, you are getting the maximum possible yield into 10 equal parts. The first unit will give 50% of maximum possible yield. So, if you divide in 10 equal parts x n, that is 20 kg per hectare, and that will give the yield, this will x n 20 kg per hectare, it will give 50% of maximum possible yield, that is 3000 kg per hectare. So, what is said, if you divide into 10 equal parts, the first unit will give the 50% of maximum possible yield, and if you go on adding, that follows Michaelis growth law. If you see the, that is 300 kg per, it is a 50%, this is the that indicates 50% max possible yield. So, if you put log A minus y, A is the, suppose A is 100%, A is equal to 100%, and to get 50% maximum possible yield, suppose y is equal to 50%, then what is the value of C? If you put log A minus y, log A minus Cx, so C will be, if you calculate C, log A minus y, log A minus Cx, or that will give log A by A minus y is equal to Cx. So, if you put A is 100%, y will 50%, that will give log 2 is equal to C. X is the first unit, x is 1, C into 1. The first unit that gives 50% maximum possible yield, then C is equal to, x is equal to 1, C into 1. Log 2 is equal to C, then C is equal to, C becomes your 0. Log 2 is equal to 0.301. So, if you put C, now you have to get C, because this Boole says, so if you divide the x axis into 10 equal parts, first part that gives 50% maximum possible yield. If A is equal to 100%, y the yield realized 50%, and when x 1, the x is equal to unit, the first unit that gives the, when A, for this x is equal to 1. First unit of application that gives 50% of maximum possible yield is 100%, then in that case C becomes 0.301. If you calculate the C value 0.301. Now, you put C value 0.301, suppose go for the second unit of x, x becomes suppose second unit, x 1 unit, x becomes second unit, then what is the value of y? You will get the value of y like the Boole unit depth says. If you go on adding the first unit that gives 50% of maximum possible yield, then go to second unit, if you put the C is equal to 0.301 and put this, the calculate, the y will become 75%. If you go on adding the third Boole unit, that will become 87.5%. So, if you go on adding this one, see the first unit, second unit, first unit gives 50% maximum possible yield, second unit gives the increase the yield by 25% over the first unit, and the third unit increase the yield by 12.5%. That means, with each successive addition of growth factor, the yield enhancement is lower. As you go on adding growth factors, the increase in yield is lower. So, as you have shown this example, so if you go for the A is equal to the first the maximum yield 6000 kg per hectare, if you go for the input application like x 1, and if you go for the yield, if you go for the, your yield is kg per hectare, and x 1 is also input kg per hectare, the nutrient. Suppose you have the 20 kg per hectare, if you go for 20 kg per hectare, I say you will get the 3000 kg. And if you go for the 40 kg, your addition will be because 50% maximum possible yield. If you go for the 40 kg, then yield will be 1500 addition, 4500. If you go on adding up to x, that each unit the 20 kg per hectare, if you go up to 200 kg per hectare, your yield will be 6000. So, each successive addition, now the difference is 1500. If you go for 60 kg, it will be addition will be 750, that becomes 5250 kg per hectare. So, likewise, the yield increment yield with successive additional growth factor, that goes on decreasing. That is what the Mr. Lee's growth law says, because growth, the yield is not linearly correlated with your input applications. So, the addition of yield for each successive addition growth factor is smaller, that goes on decreasing. That is what also in case of our input management, we see how much input should apply, so that you can get the maximum productions. At the same time, it should be profitable, not that we can go on adding and that gives maximum yield, but not profitable. So, in case of modeling also, we see when you go on adding nutrients, how much nutrient you can go on adding, so that you can maximize production. At the same time, we have to see how you can maximize the return. That is what the growth law states, and this growth law also applicable when you go for the modeling exercise, the modules and programming also, that take care of the input and output correlationship. So, from this we can see from this lecture, the crop growth is influenced by this by the climatic and the edaphic factors, which operate together to determine the crop performance definitely, and growth generally followed the sigmoid growth pattern, and the yield relations with the input management is never linear, because that follows the growth law like as a Mr. Lee's growth law. Increase in yield with increasing additional growth factor is progressively smaller. So, that is what we have to go for the proper input management to have the maximized production. You have to set the points where you can apply the fertilizer, so that we can get the maximum production. So, the proper understanding of the management of the growth factors and helps to achieve the maximum yield, resource use efficiency, and long term sustainability definitely. So, that is what, if you know the relationship, the inputs and the output your yield. So, how much input to be applied, so that you can maximize productions, at the same time we can make a good profitable. So, these lectures whatever the principles we have followed growth law, that will be applicable for this in case of crop modeling and simulation exercises, and that gives understanding of the proper input management for at the right stage and the right quantity. We have to know how much quantity should apply, so that we can have the maximum productions. With this, I thank you all. Thank you.